Hey, what's up, gang? You guys did a great job with that first combo circuit. You smashed it, you destroyed it, you obliterated it, you equalized it, you did all the things that you could do to that circuit. So let's do another one. Why not, right? Okay, so we're looking here at another combo circuit. This one, add in another layer of complexity, but nothing you guys can't handle. We're going to do this one too. All right, so let's take a look at what we got. We're going to walk through it. We're going to figure out what we're trying to do with this bad boy, and we'll take it one step at a time. So first things first, we need goals. Our goal is we're we're completely omitting current and voltage in the circuit. We're looking only at resistance, and we're going to try to find the elusive RT, or total resistance. That's what we're shooting for here. Let's take a gander. We've got 4 resistors, all with varying levels of resistance, and it looks like we've got R1, and then in line directly after R1 is a parallel circuit that actually has, a parallel branch that actually has 3 resistors, 2 in series and 1 on its own little branch. So, in order to find total resistance, our goal is simple. We need to reduce this down as best as we can into a simple circuit, right? With no branches, no obfuscation. We just need to make it happen as simplified as possible. Essentially making all of this look like one big resistor. So let's try and look at this logically, pragmatically. How can we find a way to shrink this down and make this a single resistor or single circuit? I'm seeing a couple options here, and I hope you guys are seeing the same thing. I see this parallel branch right here. Actually, we've got 2 resistors in series, which we know off the bat we can shrink down to 1. Really easy, simple math. And then that leaves us with a parallel circuit. Now, if we take that parallel circuit and we can shrink that guy down into 1 branch, then we have 2 resistors in series, which again is just simple math. And from there, we've got our total resistance. So I think this should be quick work. I'm not sure, but I got a good feeling about this. Let's take a walk. So I'm seeing R2 and R3 as a great candidate to be simplified down into a total resistor R2, R3. Let's take a look at this guy together. So we know in order to get total resistance for resistors in series, we just need to add them up. So we're going to say, uh, here's our symbol for in series resistors. We know we need to take R2 and add it to R3 in order to get R2, R3. So let's just switch out these values, right? Looks like we've got R2 has 3 ohms. I'm looking right here, looking at you, R3, excuse me, R2. Then R3 has 9 ohms. So let's add that together, 9 ohms, which means our new resistor that we can produce from this, theoretical of course, R23, is actually equal to 12 ohms. Bam, we did the first of 3 steps, and that was quick, simple math. So essentially, what we did was we took this entire branch, we just nixed that guy, and we made it look like there's a 12 ohm resistor right here. And we'll call this R2, R3. Boom. Okay, so we're almost to the point where we have a series resistor. We just have this pesky parallel branch in the way. That's comprised of R2, 3, and R4. So, besides my wife going aggro on a cat, let's figure out how to shrink this parallel circuit down. So, we know the formula for parallel resistors to be simplified is a denominator of, we'll say, In this case, it's R23 plus R4, all as a denominator under 1. But if you take a look at this, R23 is 12 ohms. R4 also 12 ohms. Guys, if you pay attention, you're going to realize I'm going easy on you. We've got parallel circuits here that are same values. So what we need to do is just divide that by 2, because this is the same as saying that's pretty much the same thing. Bam. All right, so let's get this out of the way. We just handled that parallel branch right there. What did I say it was? 6 ohms. So we could scratch the, whoops, wrong brush, scratch this and scratch this. And essentially this entire branch right here now appears, at least in theory, like this. As if it's a, two series resistor circuit, which is comprised of R1, and I'm going to do this funky notation right here, R2 through 4. And that is equal to 4 ohms for resistor 1 and 6 ohms for resistor 2. Now we have a series circuit, and we just add these guys up. Remember? First resistor plus the second resistor, add those resistances together. So we can say that R1 through 4, also known as total resistance, is equal to 10 ohms. Man, I think you guys are beating your record time. That was a harder circuit than the last one we did, and I think you did it in half the time. Nailed it. Awesome, guys. I will see you in the next video, and we're going to add one more layer on top of this one. All right. Thanks for watching.